Now we can work on the triple integral part of our problem or our proof, this right over here. And so I can rewrite that. So this is the triple integral over our region, which we're assuming is a type 1 region, of the partial of r with respect to z, which we could write like this. Doesn't matter. Partial of r with respect to z, and I'll dv. And we can rewrite this as, we can assume we're going to integrate with respect to z first. So I'm going to integrate with respect to z. Let me do that in another color. I'm going to integrate with respect to z first. The lower bound on z in our type 1 region, the lower bound is f1. The upper bound is f2. So we're going to integrate from f1 of xy to f2 of xy. f2 of xy. And I'm going to integrate the partial of r with respect to z. So let me do that in that same yellow color. Partial of r with respect to z. And then I have dz. And then I'll have to integrate with respect to y and x, or with respect to x and y. So it's dx dy or dy dx. I can just write that as dA. So what you could think of it, we can evaluate the yellow part, and then we're just going to take the double integral over the xy domain. So this is just going to be over the xy domain. So let me put some brackets here, just to make it clear what we're going to do. So all we're doing is we're integrating with respect to z first, and we have the bounds there. Well, this is pretty straightforward. This is all going to be equal to, I'll write the outside first, the double integral over the domain, and I have the dA right over here. Actually, let me give myself some real estate. dA. Well, what's the antiderivative of this? This is just r. And this is just r, or r of x, y, z, evaluated when z is f1, or when z is f2. And from that, we evaluate it when z is f1. So this is just going to be r of x, y, and z, and we evaluate when z is equal to that. And from that, we subtract it when z is equal to that. So that's going to be equal to, so r of x, y, z evaluated when z is equal to that is r of x, y, f2 of x, y. And from that, we need to subtract r when z is this, minus r of x, y, f1 of x, y. And then make sure that we got our parentheses. Now, this is exactly what we saw in the last video. It is exactly that, which shows that this is exactly this. So when we assumed it was a type 1 region, we got that this is exactly equal to this. You do the exact same argument with the type 2 region to show that this is equal to this, type 3 region to show this is equal to that, and you have your divergence theorem proved. And we can consider ourselves done.